Hello, I'm here talking about the informal definition of continuity in case that math notes box doesn't make sense, or you just want to hear a little, want to hear Mr. Hein going over it, who knows. But take a deep breath, be in the moment, try to clear your thoughts for just a few minutes. I'm only going to do one now. You can do more if you want to. Now, informal definition of continuity basically means that you don't have to lift a pencil to draw the graph. Anywhere on its domain, which domain just means left to right. And that's the informal definition. The formal definition is very important. We'll get to that, but chapter 1 is just a preview of this. So here's a good example of it. I hope you see this. So let's look at a piecewise function because it's made of two pieces of just say 2x plus 1 on the domain of x is less than 0. And then we'll look at x squared on the domain, or x squared plus 1 on the domain x is greater than or equal to 0. All right, so if I was to graph this piecewise function, we know it's at 2x plus 1 means you go up 1, and you go up 2 over 1, down 2 over 1, down 2 over 1. So it's this, and it's for everywhere x is less than 0. Notice that there's no equal sign, so we'll do an open circle there and do something like that. So that covers the first part of that piecewise function. Then the second part is it's x squared plus 1 at 0. But if I plugged in 0, where are we at? If you plug in 0, 0 times 0 is 0. 0 plus 1 is 1. So you're at 1, which is actually that same point, because you're at 0, 1. So that's part of the graph. And then x squared, it's just a parabola, so we'll just sketch it. And notice that this is continuous because I don't have to lift my pencil anywhere at it. At that point where the pieces change, I'm still actually at that same point. A non-example would be something as small as 2x plus 1 for x is less than 0, and if the second part of that was, say, 3x plus 3 when x is greater than or equal to 0. Because what you'd see on that graph is you're at this graph, which is at 1, open circle, and it's going down 2 every time. And then this one, however, at 0, if you plug that in, you are at 3, so 0, 1, 2, 3, and then you're going up 3 every time, which would look something like this. Sorry, I got confused. And notice that this graph does not connect. I mean, you can't, continuity is another word for connect. That's kind of the key word there. And the problem is when they were creating this in Latin, it's unfortunate that when it gets transferred over to English, continuity as a word in English that we think means forever. If something is continuous, it goes forever. But really what it means is it connected on its domain, however short or however long or infinite that is. But this one's not continuous because you have to lift up your pencil. Okay. So that is continuity. Informal for now. We'll get to the formal definition later, but definitely the big thing to know is continuity just means, is it connected? All right.